Okay, welcome to part 2 of our review video. So if we keep going here for number 6, the graph of which function has an amplitude of 2 and a period of 4 pi? Well, as soon as we see amplitude of 2, we know we can cross off 3 and 4. Because remember, when we're talking about the equation of this sine graph, we have a sine bx plus c. A is the amplitude. So we know that the amplitude's 2, that's in front, those two gotta go. Now, B is our frequency. So 4 pi isn't just what goes on here. Remember, the period is 2 pi divided by B is the equation to find that. So in this case, they're telling us that 4 pi is my period. So I'm going to stick this over 1, just cross multiply. So we have 4 pi B equal to 2 pi. And we're getting B by itself, so I'm dividing 4 pi to both sides. Well, that cancels, so we have B equals, pi's cancel, and we simplify to 1/2. So it's going to be choice 1. Okay, a lot of people will choose choice 2 because they're not looking quick and they just assume 4 is still there, but they just ditch the pi completely. So be careful with something like that. Okay. Relative to the graph of y equals 3 sine x, what is the shift on the graph? So remember, we're inside the parentheses, which means it's a horizontal shift. So 3 and 4 are gone. It would be outside of those parentheses if it was vertical. And remember, it goes the opposite, so it's really going to the left. Now, you don't really have to deal with graphing any horizontal shifts. You just have to be able to read them for multiple choice question purposes or like descriptions. Which graph represents a cosine function with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? Well, a couple of things to look for here. First thing I'm going to look at is the fact that it said cosine. So that means 2 and 4 are gone because cosine either starts above or below the midline. And in this case, the midline here is where they're starting. So those two are sine curves. So that can't be cosine. So now we're down to a 50-50 shot. Now this is no horizontal shift, so that's present in both of them. That works for us. Amplitude of 2. So they both have an amplitude of 2 because it goes up 2 and down 2 from the midline, down 2 and up 2. So we just have different directions, but the amplitudes both check out. Now, here's where we want to be careful. The period is 2 pi over 3. Now, remember, the period is for one cycle to complete. So there's no way it could be choice 1 because if we look, we have 1, 2, 3 cycles happening by the time we get to 2 pi over 3. So for us to get one full cycle, look here. Here's 1, and that's about 2 pi over 3. We don't even have to really get into proving that it is, but from 2 pi, notice if we wanted to check here, there's 1, 2, 3 for the frequency. So I couldn't simplify that anymore. It's choice 3. Okay. We have another graphing one here to graph one complete cycle of cosine negative 3x, negative 3 cos 4x plus 2. So first things first, remember you have your midline to consider. There's a vertical shift. And then we're going down 3 and up 3. So we're looking at 5 and negative 1 as your max and your min. We know there are 4 increments that we care about. And we're going to calculate the period here. So we were already done part of half pi for us. So 3, frequency is 4. So we're looking at 2 pi divided by 4. So it's going to be this simplified to pi over 2. So that's the period for one cycle to finish. And then to get our important values here, we take this pi over 2 and we divide it by 4. So we're looking at pi over 8. So that's here. And that just counts as I added that again. Pi over 8 plus pi over 8 is 2 pi over 8, 3 pi over 8, and 4 pi over 8, which does simplify to pi over 2. Okay, now because cosine, we start either above or below, but never on the midline. And because it's negative, we're starting below and then working our way up to the midline, up past the midline to the max, back to the midline, and below, making sure it is curved as we go through. Okay, and that is going to be my one complete cycle of this cosine function. Okay, the terminal side of theta, an angle in standard position, intersects the unit circle at these 2 points. What is the value of cosecant theta? So if we're thinking about that, remember xy in this case, that's the same as cosine theta and sine theta. So that being said, cosine theta is negative square root of 40 over 7. Sine theta is negative 3 over 7. Well, cosecant theta is the reciprocal of sine. So all we need to do in this case is get the reciprocal of negative 7/3. Okay. Which function is even? Now, an even function, we could go and check with an algebra and plug it in. But remember the easiest way to tell. I would look at the graph. An even function is a graph that when you look at the picture, it's symmetric to the y-axis, meaning I could fold my picture in half along the y-axis and it would be the same on both sides. So I'm going to borrow my calculator and I'm going to go in and type in sine of x. Now when I graph it, remember, I ended up seeing it not too bad here. You could always zoom 7 for a trig just to see it a little bit better. But notice, if I fold my page along the y-axis, this is not going to work. This is actually an odd function. If I turn my calculator upside down 180 degrees, this is symmetric over the origin. So this is no good. So we're going to try it for cos. This one does work out, right? If I folded my page along the y-axis, it's definitely symmetric. So choice 2. Okay. You can plug in the other 2 options as well, and they won't work. All right, throwing it back to factoring. So it's been a while. Just make sure we're not too rusty. Do substitution, because remember, in those parentheses, when you have that repeat, that's when we're going to borrow the u's. So u squared plus 10u plus 24. Now I should be good and make sure I write a let u statement, like let u equal x squared minus 5x, just so we have it. But this is just the regular AM method then. So it's u and u. We want what adds to 10 multiplies to 24. So it's going to be 6 and 4. Now, once you're here, we put back what we borrowed. So it's going to be x squared minus 5x plus the 6 that we just got. And then again, we're putting the u back as x squared minus 5x plus 4. And now we're going to see if we can factor any more. So on my left, we would have x minus 6 and x plus 1. Oh, wait, no, we would not, because that would not multiply to a positive 6. So, my bad. We would have x minus 3 and x minus 2, okay, because those two would add up to a negative 5, and they would multiply to a positive 6. So be careful. I almost fell for a trap there myself. Then in the second part, we're looking at, this time we would have x minus 4 and x minus 1, because we want to multiply to a positive 4, so a negative and a negative make the positive, but add up to negative 5. So as long as you had those 4 factors, they could be in any order, and you'd still get full credit. Another throwback here. So it's just telling us to multiply f of x and g of x. So I'm saying I have 2 to the 3x plus 5 times 2 to the 2x minus 3. You need to remember your exponent properties here. So notice you have the same base of 2. Now all we do is add the exponents. So I'm taking 3x plus 2x to get 5x. 5 plus a negative 3 is a positive 2. Simplest form, done. Don't overthink it. Just remember your exponent rules there. Okay. If theta is an angle in standard position and its terminal side passes through negative 5, 1, what is the exact value of secant theta? So, in this case, you can use your unit circle to help you if you would like. But think about where negative 5, 1 would lie. We're going to make the right triangle there. So negative 5, 1. Okay. So for this particular one, we can find here, we have to find the missing side of the right triangle. So whenever you're missing one side of a right triangle, remember we use Pythagorean theorem. So I'm going to have negative 5 squared plus 1 squared, because the hypotenuse is always the missing side. Or not, excuse me, not the missing side. It's always the one across from 90, so it's always the biggest side, that hypotenuse. So we'd have 25 plus 1 equals x squared. 26 equals x squared. And we would take the square root. So square root of 26 is this missing side for us. Now that we have that, theta is considered to be this angle here. So you have the opposite side, the adjacent, and the hypotenuse. Well, we want secant theta. Secant is the reciprocal of cosine. So since cosine theta, when we find it, is adjacent over hypotenuse, secant theta is hypotenuse over adjacent. So the hypotenuse we just found is the square root of 26 over the adjacent of negative 5, which does check out because, remember our phrase for ASTC, it's in the second quadrant, so cosine is negative, which means secant is also negative. So negative radical 26 over 5. And it doesn't matter if the negative's in front or on top or bottom, but whichever works, as long as it's only there once. They filled this one in for us. In which quadrant does theta lie if the following statements are true? So it's saying that secant theta is positive, just like cosine. So you notice like my light blue checks are for quadrant 1 and 4. And tangent theta is negative, so it's in quadrant 2 and 4. They overlap at quadrant 4. And finally, find the exact value. Remember, you're supposed to have that chart memorized, but lucky for you this year, you can kind of look back to it. But we use that phrase QSFR to solve for tangent. So I converted the 4 pi over 3 into degrees, found the quadrant. The sign would be positive in the third quadrant. Tangent is the function. Reference angle is 240 minus 180. So tangent of 60 is radical 3. Cosine of 180, however, you can just plug that right into the calculator. It's off the unit circle as negative 1, right? It's 180 and it's the x value